So we had a null hypothesis that service was the same between the cities and the suburbs, and we failed to reject that null. So now it's your turn. So do the same analysis for decor and cost. Is decor different between the city and the suburbs? And is cost different between the city and the suburbs? So our null is that they are not, and we may or may not be able to reject it based on our data. Okay, so pause the video, have fun, and then see what you get. All right, let's flip over to our PASW and confirm what you did. So we will be doing independent samples T, but now for food and decor as well. Our assumptions of equality of variance was justified for all three of these. And let's look at the means here quick. So this is the one we already saw. These, all right, that is food here. Not particularly different, and decor, not particularly different. And we can confirm that here by noting that these t statistics are small and that the significance level, this significance is not below 0.05. So we would fail to reject a difference between the city and the suburbs for all three categories. Notice that these are negative, so t's are negative when the second group is smaller than larger than the first group. So here, this is bigger, then this is bigger. So we have a negative, negative, positive. So what if the variance was different across the groups? So instead of doing a pooled variance t-test, we would do a separate variance t-test. So the math for the separate variance t-test is quite a bit different than the pooled variance t-test, but because we're doing both tests within PASW, they will look the same. So even though we're doing something fundamentally different, the output is similar and the results are similar. If the variance was equal, then you won't get much difference, but if our assumption of equal variance was wrong, the pool variance t will be quite a bit different from the separate variance t. So we can go ahead and try it. So recalculate difference in cost between city and suburbs, assuming the variances between the two groups are different. They're not. We tested and showed that they're not, but we can assume that they're different and run that test. So go ahead and try it. Okay, we'll flip back to PASW, and actually, so this, oops, here we go. So there's our output, and oops, wrong one. Let's see, here we go. We can just do compare means, independent samples t. So under the assumption of not equal variance, we would read off the bottom line. So for these, we have the same t-statistic. So actually, assuming variance was not equal, didn't produce a difference for any of the three categories because the variances were equal. So assuming that they weren't, what doesn't create a difference in the t-statistic. These numbers here would have been different had the variances been different. And so that brings up ANOVA.